All right, so we should put pink sheets away because we got notes to do before you can even remotely begin to do pink sheets. Okay? So, let's talk about the population of the state of Pennsylvania throughout the 1900s. Okay? Now, from U.S. histories, what can you tell me about Pennsylvania in the early 1900s? What? It did exist. Well, it did exist. It was one of the original 13 colonies.
I barely passed history classes for that one.
What can you tell me happened in the early 1900s? Two big events.
The Prohibition.
Okay, that really wouldn't affect Pennsylvania.
I just said
A war, World War I happened. Okay. What else happened? Think about what Pennsylvania is known for.
Doesn't involve Hershey's chocolate.
Nope.
What?
Hershey, Pennsylvania.
Oh.
Penn State.
Is it the Liberty Bell?
Think about what Pittsburgh is known for.
Penguins? Baseball.
Penn State.
That's all I know.
This is not good.
When I say I don't like history, that means I don't pay attention to
Can I
history.
Google it?
What? I don't hear what you said. No, that's Civil War. That's 1800s.
We all suck at history.
Pennsylvania has two main exports: steel and
Oil.
nope.
Iron. Tin.
Steel. What makes steel?
Metal.
Nope. Nope.
What?
Coal.
Oh.
Okay.
Yeah.
So what happened in the early 1900s was something called the Industrial Revolution.
Oh, yeah.
Oh.
I heard about that 2 years
I
ago.
Yeah. You guys make me worry for my future. Okay.
Yeah, you should.
All right.
Yeah, you should.
So if coal is needed to make steel, and steel is needed to fight the Great War, because at that time World War I was called the Great War, okay, what would you expect Pennsylvania's population to look like?
To go up. Go up.
To go up how?
A lot.
Exponentially.
Exponentially, right? Okay. So you would expect that Pennsylvania's population would rise exponentially. Okay. And it does, or it did. Okay. But then what happened at the end of the 1920s and the early 1930s?
The Great Depression.
Great Depression. So steel production and coal production slowed down a little bit, right? Okay. Then what happened in the 1940s? World War II. Okay. So population probably would go up, right? Because we got to fight another world war, so we need all that stuff. So here is the 1940s, and 1930s and 1940s, it slowed down, and then it picked back up again. And then my question to you is, would an exponential model be the best to fit this data? Why not? Because what?
It doesn't move exponentially. It's not like
It's pretty steady.
just.
What do you mean?
To a certain point,
You're going to have a limit, right? Pennsylvania is only so big. You can only fit so many people in that state. Okay? Before you're stacking 3 or 4 people on top of each other's shoulders. Okay? So you can only fit so many people in Pennsylvania. So an exponential model goes on forever, and it's unbounded. Okay? if we followed an exponential model for this, there would be like 50 million people living in the state of Pennsylvania right now, okay? Which is not true. Okay? So in order to deal with that, we have something out there called a logistic function. Exponential growth is unrestricted. It continues to increase at an ever-increasing rate and is not bounded above. However, in many situations, there is a limit to growth. Like, for instance, trees for plants. Okay? I plant my corn in the spring, and my corn grows exponentially, and then it levels off. Okay? It levels off at about 12 feet. So that would be my limit to growth, 12 feet. Okay? Population of a city can't grow exponentially forever. Sales of a new product can't grow exponentially forever because suddenly people that already have the product are going to be buying it again. Which probably isn't true. A logistic function starts along its horizontal asymptote, then grows exponentially, and then levels off. Logistic functions have two horizontal asymptotes. One of them is at y equals 0. There can never be negative 32 people living in the state of Pennsylvania. Okay. This upper one is what we call the limit to growth. Logistic functions take one of two forms. The one on the left is the one that we prefer. The one on the right deals with e, our exponential number. So a logistic function is the function in the form c divided by 1 plus ab to the x power. What do you notice about the denominator here on both of them? There's a 1 plus. Okay, what else do you notice? The denominator. So we're just looking at the bottom. What else do we notice about the bottom? Always greater than 1. No. What do you notice? Think about back to yesterday.
X is always the next.
So if the variable is always in the exponent, it's, say it louder, it's exponential. The denominator of a logistic function is an exponential function. Okay. A, B, C, and K are positive constants, and B is less than 1, but greater than 0. What does that mean now for the exponential function below in the denominator? if b is between 0 and 1, what does that mean for my exponential function in the denominator? I can tell you guys did not do your homework. What does it mean? What does b being between 0 and 1 mean for our exponential function in the denominator? What? That's it. So it's a decreasing, it's an exponential decay function in the denominator. Okay? So it decreases, which means as you get farther and farther and farther to the right on the graph, right? So if I get bigger and bigger and bigger values of x here, b is less than 1, so this number is going to 0. Since this number is basically 0, 0 times a is, that was an easy one. 0 times a is 0, plus 1 is 1. So c divided by 1 is c. So that's why it gets closer and closer to c as we go along. Okay? Now, if b is greater than 1, then we have a logistic decay. So it starts with a lot of stuff, and then it decreases exponentially, and then it levels out, and at the end, then, it would be closer and closer to 0. Okay? So, let's make a logistic function. I want to be of the form y equals c over 1 plus a b to the x power. What do I know? I need to come up with C, A, and B, really. Yeah, 3 things. Okay, so what is that? A. Do we agree that A is 12? I don't. In an exponential function, yes, A would be 12. But we're not in an exponential function, are we? No. So A is not 12. What else do we need? What is C? C is 60. Okay. What should we find first? Or what's an easy point to use in our function? 0, 12 is an easy one, right? Okay. So, if I utilize 0, 12 in my logistic function, that would tell me that y is equal to 12. C is equal to 60. 1 plus AB, x is 0. B to the 0 power. 1. 1 times A. A. So this is 12 equals 60 divided by 1 plus A. What do you want to solve for? A. The only thing you can solve for. How are we going to do it? Multiply both sides by 1 plus A. Then what? Distribute if you want, or divide both sides by 12. Either one doesn't matter to me. And then subtract 1. So our A value is 4, which is not 12, right? Okay? But that's just a coincidence. Okay? All right? What else do we need now? We've got C. We've got A. We need to find B. Okay? So I'm going to use another point that my logistic function goes through to find it. So what's the Y value? 24. What's my C value? What's my A value? What's my X value? 1. B to the first. B times 4. 4B, right? Okay, all right. So this is 24 is equal to, oops, excuse me, I misspoke there. 24 times the quantity 1 plus 4B equals 60. What do you want to do? Divide by 24. Okay. So that gives me 1 plus 4B equals 5 halves. We like fractions for B. Subtract 1. So if I subtract 1 on this side, what am I really subtracting on the right side? 2 over 2. Then what? Divide both sides by 4. Dividing by 4 is really multiplying by 1/4. So B is 3/8. So my logistic function is y equals 60 divided by 1 plus 4 times the quantity 3/8 to the x power. Do I have an exponential decay in the denominator? Yes. Then I have a logistical growth function. What I'd like you to do now is I would like you to come up with this one. Spot check, did we all get A as 5? Okay. Sometimes our initial value might also be our A value. It just was a coincidence. Now what? Cube root both sides? Okay. So I get B here is 1/5 to the 1/3 power. It is a crazy fraction, yes. Okay. And again, we leave it in fraction form because when we go now to make our function, y is going to equal 30, 1 plus 5 times 1/5 to the x over 3 power. Because when we're taking a power to a power, 1/5 is taken to the 1/3 power, then that is taken to the x power. We multiply those exponents.
Where do you get B to the 3rd?
Because my point was 3, 15. Let's graph one. Yeah. Without even doing any maths, what can you tell me about this graph? What do you got? The limit to growth is 8. So that would be a, how would that go on the graph? Horizontal asymptote. Yep. At y equals 8. Do I have another horizontal asymptote? 0, 2 for my initial value. Do we agree with that? How'd you come up with that?
All the initial values wherever x is equal to 0 and anything to the power of 0 is 1, so 3 times 1 plus 1 is 4. 8 divided by 4 is 2.
So 0.7 to the 0 power is 1, times 3 is 3, plus 1 is 4, divided by 8 divided by 4 is 2. Love it. So my initial value is at 0. Actually, not my initial value, excuse me. My y-intercept would be a better choice of words there. My y-intercept is at 0, 2. Anything else that I can put on my graph? Is my lower horizontal asymptote. Okay. Starts low. Goes up, levels up. Okay. We got a minute and a half. I think we can do it. Y equals 20 and y equals 20 and y equals 0. Initial value. -3 times 0. 0. E to the 0 power. 1 times 2. 2 plus 1. 3. F of 0 is 20/3. Boom. Done. Okay? Make sure you're doing your homework.